Hello everyone, today we'll be solving an International Math Olympiad question, which goes as follows. For all real numbers a, b, c, d, satisfying the inequality that this is true, such that a plus b plus c plus d equal to 1, we need to show that a plus 2b plus 3c plus 4d times a to the power of a times b to the power of b times c to the power of c times d to the power of d is smaller than 1. Now, to analyze this, we will just use a quick method. So either they're all equal or they're not equal, right? So in the first case where they're all equal, we'll have a plus 2b plus 3c plus 4d times a, b, b, c, c, d, d is equal to 10a times a for a, right? Because here's a to the a to the a to the a. When we multiply it, we just add up. So yeah, for a, which is equal to, well, here we can just spot that from our condition, this, right? So this is equal to 1 plus b plus 2c plus 3d, which is equal to 10a, right? Meaning, since they're all equal, 1 plus 6a is equal to 10a, meaning a is equal to 1 over 4, meaning that we'll have 10 over 4 times a to the power of 1 over 4 times 4, which is equal to 10 to the power of 10 over 4 times 1 over 4, which is equal to 10 over 16, which is less than 1. So for this case, we have successfully proven the inequality. Now for the case where they're not equal. So we'll just leverage the fact that x to the power of x is equal to e to the power of x ln x. And for x between 0 and 1, right, we'll have that this is less than e to the power of minus x, since ln x on the interval from 0 to 1 with 0 excluded, because for 0 does, yeah, actually let's include 1. This ln x, it is smaller than 1 minus x. This is negative basically. Ln x negative. Afterwards, of course, it goes logarithmically like this. So here it's 0, here it's negative, tending to negative infinity, so on. So x to the power of x for all values of x is smaller than e to the power of x, which grows like this, meaning we'll have a to the power of a being smaller than e to the power of a. Similarly, b to the power of b would be smaller than e to the power of b, and so on and so forth. Similarly, for negative, for numbers on the interval from 0 to 1, we'll have that smaller than minus a minus b, right? But that doesn't matter because in our case, we have clearly stated it is more than 0. We haven't bounded it here by 1. But if we bound it by 1 to satisfy this equation, right? Because, well, if it's more than 1, this equation will not hold true. We can clearly see that it should satisfy this property, right? Because it will be on the interval from 0 to 1. Either way, we'll have a to the power of a smaller than e to the power of minus a, b to the power of b smaller than e to the power of minus b, c to the power of c smaller than e to the power of minus c, and d to the power of d smaller than e to the power of minus d. We'll rewrite this equation by saying we'll have 2b, right, plus 3c plus 4d times AA, BB, CC, DD smaller than a plus 2b plus 3c plus 4d times e to the power of minus a, e to the power of minus b, e to the power of minus c, e to the power of minus d, right? This is just equal to e to the power of minus a plus b plus c plus d, which is equal to e to the power of minus 1, as we have seen here, just due to property of logarithms. This is, well, bigger than 1. However, not by a lot, because we can clearly show that for any values of b, d, c, a that belong to integers, right, the inequality doesn't hold true. Therefore, there is a certain bound, right? Let's call it k, right? For which the inequality, well, a plus 2b plus 3c plus 4d, yeah, it is smaller than k, which is smaller than e, and this is also larger than 1. So it belongs to the interval of 1k, with both k and 1 excluded, of course. Okay, so we have this inequality, a plus 2b plus 3c plus 4d. The lengthiest part in this solution is just rewriting the expression many times over. Smaller than a plus 2b plus 3c plus 4d. Let me just shift this over e, which is smaller than 1. Therefore, by just removing this term due to the transitive property of inequalities, we can state that this is smaller than 1 for all positive real numbers a, b, c. Q, E, D. Quod erat demonstratum.